the third one is responsibility given aside to each member through assignment of roles, as we have said before. So the three roles that we have used are the numeractor, the artist, and the reporter. And Julia already presented them, so I'm not gonna in depth about what is their feature. Briefly speaking, the numeractor relates to the register of numbers, the artist relates to the register of graphs and visual products, the reporter is related to work on the register of language. We have already seen that for mathematics learning are very important the treatments of a register, so working within a register and the conversions among registers, and also that how much they are relevant to understanding also in mathematics teaching and learning. And this is something that has been studied in research. So it was an assumption for the work that we developed. In the design of our activity, we aimed at introducing early algebraic thinking, but there is a reason for this choice. It was not a random choice, and the reason is the fact that the focus of the project in terms of mathematical content was numeracy. So since numeracy, one part of the competence that is related to numeracy is the use, for example, of numbers to solve problems, we find early algebraic thinking as relevant to this kind of competence, and also relevant to the age of the students that were involved in the ideas of the project, in the work of the projects, that were students from the very end of primary school to the very beginning of secondary school. So early algebraic thinking is just a central element of the passage from primary to secondary education. So the choice was not random. What I'm gonna present here are some concrete examples that are related to some of the activities that we have been designing, trying to exploit the methodology of cooperative learning in mathematics. The three examples have a title. The title, you can see them here. Tile frames was the first activity, the token game, the second activity, and the big party, the third activity that we developed. And for now, I'm gonna speak about one of these activities, which is tile frames, the first one, in which we essentially try to design the activity focusing just on a group work with work within the group, with what we have called within interaction between the members of the group, which means that the groups were made of three components, were called base groups, and you will understand why they were called base groups in a minute. And they were, each of them was composed by three different roles, so members to which were assigned three different roles: a numerator, an artist, and a reporter. And this was part of the didactic methodology through which the students were always working within the classroom in all the three activities that we designed. So I'm just gonna a little bit in depth about the content and the context of the first activity. Tile frames is an activity that relates to a context involving square frames like the ones that you are seeing here. And for example, both these are examples of a 4x4 frame, which means a square frame that is made of square tiles, and the number of tiles for each side of the frame gives the format with which we name the frame. So in the case of the 4x4 frame, we have 4 tiles for each side. And one of the points that we wanted to work on in this activity is the fact that the number of tiles along one side of a square frame is related, is connected to the frame format. The other element, the other aspect that we wanted to focus on in the activity is the general structure that we can give to a tile frame like this one. So, for example, we can see 4 pieces that are made of 3 tiles each, like in the video that you should have seen before. At the same time, we can also relate the 4x4 frame to the following frame, so to a 5x5 frame through a recursive role. For example, we can see that we can get a 5x5 frame simply adding 1 tile for each side to the previous frame. So this means that if the 4x4 frame is 4 times n minus 1, the 5x5 frame is that same number of tiles plus 4. And all of this allows us to work on the fact that the number of tiles practically is a function of the sides, so of the format of the frame. Why I'm saying this? Because for this, the structural part was very relevant to work on numeracy and on early algebraic thinking in our activities, and also because we can profit of the fact that there are different points of view from which we can look at the same frame. For example, we can look at the 4x4 frame thinking of 4 times 4 tiles, which means each side counted once, minus the 4 corners that, the 4 tiles at the corners that are counted twice. Or we can simply look at 2 times 4 plus 4, which is a completely different structure, completely different from the algebraic point of view, so from the way in which we are using the symbols, so the symbolic register that Julia was saying before, but equivalent to the other structures in terms of the total number of tiles that we can get. And this is an important premise. I forgot that there was also the animation accompanying all this discourse, but at least you can see the different blocks that I was speaking of. What we did, so in tiled frames in this activity, was to design 2 different, let's say, moments in the activity. In some moments were devoted to base group work. Some other moments were dedicated to interaction among base groups. And so what we have called 1 at home and 2 moving around, that were focused on explorative phases. There were 2 people in a group that were going into exploration in the other groups. And the 2 people moving were not always the same. So according to the different roles, even different peoples were moving across the different base groups. So this is the context of the activity, a grade 4 activity. And we implemented this activity in 2 different grade 4 classrooms. And what I'm gonna present you now are some examples that are coming from the creative products. Julia spoke before about different creative products that we can get in terms of pluriliteracies from the work of the students inside the classroom. So I'm going to show you some concrete examples that are coming from the classroom in these terms. And I don't want to comment more on what you are seeing on the screen, because it is something that somehow we have already discussed. You just need to know that we videotaped the activity. We randomly assigned the roles, and that the activity in total took 8 hours. And there were different kinds of tasks, of course, associated to the activity. One is the direct task, so finding and generalize it, the number of tiles based on the frame format, but also the inverse task, so starting from a frame format based on the number of tiles. So this is the first example. This is the first example that comes from the classroom. Here, the question, the specific question of the activity was asking to look carefully at the figure. There was a figure that was given, like this one, or like this one. Well, this has been worked on with all these 9 little squares added inside. But at the beginning was, and also this one, sorry, I just make a step back. We use 3 different kinds of representations within the classroom. One with the corners that were colored, one with the corners that were not colored, and one that was not colored at all. So just to somehow foster, stimulate the different points of view to look at the structures that I was recalling before. So thinking, for example, that this can be 4 times 5 minus the 4 angles, and this can be 4 times 3 plus, for example, the 4 angles. So coming back, this is an example in which what happened in the classroom, trying to answer in a base group to this question. Look carefully at the figure. The figure was presenting a 5 by 5 frame. What do you observe? Different groups have worked on the diagrams in a similar manner. How? Adding an internal square and taking into account in the way they were looking at the figure and also at the number of tiles that the figure is composed of. There are other examples that are similar. The one on the left just takes into account the fact that in this case you have 14 white squares, but the same thing happens also changing the question that was made to the group. Like, for example, in this case, the question was saying, focus on the number of tiles, how many tiles for a 4 by 4 frame. And in this case, we can see, now you cannot read here, but practically the total number of tiles is found in this case considering the total number of squares that squares of tiles that stay inside this 4 by 4 frame minus the tiles that compose the internal square. So 16 minus 4 equal 12, where the 4 are the inside tiles. So this is to say that there is a different structure that comes out from the work of these students and that influence the way that the students are answering the question in the activity. 5 minutes. Okay, perfect. Thank you. So this is instead another example coming from the classroom on a different question. The question was saying, imagine constructing new square frames in the same way. How many tiles for a 6 by 6 frame? And here what we can notice is the recursive role and the recursive relationship that that characterizes the way in which a 6 by 6 frame can be related to a 5 by 5 frame. So these students already knew the number of tiles for a 5x5 frame, and they have simply written on this protocol, we have added one little square to each side of the frame, the 5x5 frame. So 16 total number of tiles for the 5x5 frame, plus 4 total of little squares added, equal 20, which means that, for example, in this case, it is the recursive reasoning that is influencing the way they are looking to a partial structure, a local structure that is just about the relationship between one figure and the successive figure. And then I'm going to show you some unexpected answers that were unexpected because they speak of different kinds of looking again at the structure of these frames. For example, you can see here 2 columns that contain 4 tiles plus 2 rows that contains 2 tiles. And the same it's in this case where we have here a 6x6 frame. And the question is the same as the one that we have just seen before. We changed the question again. This question was asking the students, you want to construct a 20x20 frame. So we are going to have, in this case, a bigger frame, a farther frame from the ones that we have been using. And the students cannot reason, for example, recursively. So we are asking how many tiles do you need in this case? And they have to answer without drawing the tail. And in this case, the reasoning that is occurring is exactly that one that is similar to what was happening here. So it is considering 20 plus 20, 20 times 2, which is 40, and then 18 plus 18, which are the other 2 rows, let's say. The same a similar reasoning. It's not the same. In this case, there is a different structure which is even more partial than the one that we have seen before, because we are considering here 20, which means, let's say, 1 column, the whole column, then 19 plus 19 plus 18. So instead of having, I make a step back, instead of having 4 plus 4 plus 2 plus 2, in this case, we would have had 4 plus 3 plus 3 plus 2, which is a different way, a different point of view, but on the same structure somehow. And to conclude, there were happening 2 different things that we can outline from the classroom. One is the importance of this, the relevance of these different points of view for looking at the same structure, because this became like an element for the teacher during the collective discussion to put together all the different points of view, and also trying to treat the same register, the register of numbers, for changing from one structure like 50 plus 49 plus 49 plus 48 to 50 times 4 minus 4. So I simply need to add 1 to 48, take away 1 from 50, and see that this is the same as 49 times 4 plus 4, for example. So this was a very relevant element, because from unexpected answers coming from the group work, the teacher could try to connect the different points of view and the different glimpses on the same kind of structure. And the other thing was related to the issue of roles, and so to the specific issue of having chosen to work with a cooperative learning methodologies, because we never asked the students when they were going into exploration in other groups They were going into exploration using some post-its and taking notes on these post-its and observations about the work of the other groups. But we never asked them to remain in their register of representation when they were going around. And this is an example of the influence instead of having assigned roles to this group in which two students that went into exploration in other groups came back with post-its just related to their single role. So in the case of the artist, there were simply two, you cannot see it very well, but see them very well, but there were simply two drawings. And in case of the numeractor, there were simply calculations, for example, calculations. So this was relevant in a sense, because it was not something that was asked to the students, but was something that was practically influenced by the methodology. And at the same time, you have the request to work in a group in which it's almost impossible to separate the different roles. At a certain point, you are required to work as a group to have like a common answer in which you have to convert between one register and another. And so you have to put all the information together. Well, I think I have no more time, so this was another example of the second activity, the token game, but it's a different context, but still can be modeled through a general rule, and it has a recursive structure, so it is suitable for early algebraic thinking again. And the only relevant part that I want to say here is the fact that in this case, in the case of this activity, the students are also working on a second level of interaction, which is an interaction between groups and not only within groups. So there were also groups of experts, like for groups of numeractors, groups of artists, groups of reporters that were working in this case. Well, and I think I stop here. Thank you.